So we'll start just from heat stress mitigation. We'll talk about heat island and that problem. But for me, it's really hard to separate just heat island from the rest of ecosystem services, because we must remember that we have 100 ecosystem services delivered from the nature, and even trees it's 20, and something like 5 or 6 we can calculate. So there will be something more just to demonstrate that we have tools that we can use even in a topic of heat island. I will present something a little bit more like a heat island issue. And the second part of the presentations will be cooling with trees and vegetation, and just technical parameters. So what works better? Not to prolong, and I hope my presentation will change slides. What is not? Okay, it's working. Heat stress, we experience it more often than in the past. It has some consequences. It can make us weaker. It can make us ill. It can even cause death. It happens because of heat waves in cities. The symptoms are from very weak, like just heat rash, and we need to relax, and later we can come back to work. We can have heat cramps or heat exhaustion, but when we have heat exhaustion, it's more serious, and we shouldn't return to work. It's longer time to recover. The same about heat stroke, and heat stroke, it could be even threat of death. So there is a problem. And the problem is economical, social. It's a problem of our health. And there are some informations that could demonstrate the problem. We know that full capabilities workers have at work at 23 Celsius degree, and they function, ability to work will be less with higher temperatures. So even when we have 30 degree, so it's like 70% or even less. And we know that in shade of trees will be cooler. I will deliver a lot of details, but for now, just is why it happens, how it happens. Trees needs energy just for photosynthesis. So only 10 till 30% is heating the ground. The summer and sun energy is heating the ground. It means that the places close to trees are just cooler. And there are a lot of studies, but just one example. Walls standing in the shade of the trees could be even on an average 20 degrees Celsius less cooler. What about inconvenience in the city? There are some facts that are a little bit that we are afraid of. We don't need to take Beijing as an example, but we have even the same problem in Warsaw, and we are not the hottest city in Europe. But for example, Beijing has 14 additional hot nights, even in rural areas, and on the urban areas, it's 26 additional hot nights. And the expectations are that it will be even more. In Lagos, hot nights reached 153 per year compared to 89 and 81. So it's really hard situation. What we can do? From very long time ago, there were some attempts how to mitigate heat island. In Atlanta, when the Olympic Games were planned, there was a problem of energy need for cooling. Organizers were afraid that it will be not enough energy to cool the city just for sportsmen, to prepare the games. So they planted 5,000 large trees, trunk diameter like 30 centimeters, 60,000 smaller ones, trunk diameter like 7 centimeters, and they reduced by 30% heat island. So it was a real benefit for the city, and that allowed just to organize the games. So trees can mitigate air temperature, trees and just vegetation, and I will tell you about that. The problem is bigger when we are going deeper into city center. So rural areas, they are still cooler, but city centers, dense, built by concrete, built of concrete, they are really hot. So there is relation between greenery or lack of greenery and temperature through the day and through the nights. And so what we are doing now, we are trying to bring natural processes into that concrete centers of the cities. And I will give you a lot of details about that. Now is example of Warsaw. I just added it just before the presentation. So 20 years ago, we had heat island only on one bank of the Wisła River. Now we have of both sides, thanks to different actions that city took, like 1 million trees for Warsaw, the heat island is not growing. But there, on the right side, you have nice picture about pollution and level of pollutants in Warsaw, but everywhere as well, is strictly correlated with the temperature. And atmospheric air pollution increases by 10% for every 5% increase in temperature over 24 Celsius degree. So there is strict correlation. From another side, when we are analyzing tree canopy cover is nice factor. We'll talk about it later. And when we are analyzing surface temperature, as you see, even like that, there is again straight correlation. So more tree canopy cover means lower temperatures. Even on that easy study, we can see that. How it works. So trees are taking temperature, and when we have a temperature like 30 degree, we will have 40, even 50 degree on pavements, and we can have comfort, thermal comfort, just close to trees. And I will show you a lot of examples in the second presentation, how it works, how much it works, which kind of structure, which kind of species are working better. So the differences between close to trees and outside of the trees, it's 11 Celsius degree, but it could be much more even. And I'm sure more often it's just much more. That is a Melbourne example, when we can see that is even 20, 30 degree. So lower temperature in the shadow, higher temperature on the pavements. I remember our studies when we analyzed playgrounds in Warsaw, and in a temperature of 25 degree, we got a result on play on the banks like 65 degrees. So it can happen even with quite low temperatures outside. So the problem is how to organize the public space. That is example of really nice projects, new one. It was set 10 years ago and realized. It is in the city now. We can use it. But the problem was that the beautiful place, because it is beautiful, some idea, some urban arrangement, it's that place. That place was not, people didn't want to use it because of heat. That what you see here is just little decks and little trees in pots just to make that place cooler, because it was impossible to sit and relax, and it was just not living place. That's why we even make some analysis how it works about temperature. That is normal photo, that is photo in thermal camera, and you even see that color of the pavement. So darker pavements are just warmer. That are important. Our little trees in the pots, they can make the temperature. That little trees that, by the way, are standing in the place where they can't survive. It's really hard site condition for that trees, but that little trees could make the temperature, could increase the temperature, like decrease the temperature like 20 or 30 degree, and bring the thermal comfort. That's why we just started to improve the situation. That's what you see here. It's a rebuilding of the pavement. We used structural soil just to capture water, just to organize the place for roots of trees, and we planted trees. It's hard site condition again, still for trees, but that improvement of the sites like we use, so I mean structural soil, is allowing that plants to grow, to be healthy, as you see, and that investment was something like 8-10 years ago, and you see the result now. Still, they are vital, and there is a plan to make more trees to enlarge the plantings, because that improved the situation. Not only thermal comfort, but wind, pollution, and water management. So still we have all functions together. So it's not only one function. We are proposing thermal comfort for city dwellers. No, it's a lot of functions in the same time. Again, some picture that is colored in the autumn, because they are just green trees, and in the autumn they are just like a miracle. People from the city loved it. I still have pictures. That year they look like that. Still very healthy, and they are just working for people. What is important? That is study of St. Jimmy organization. They made research on Polish population. They asked significant group of people in Poland, and they asked what they want from the urban greenery. I translated some of maybe the most important points. If they want more lawns, if they want intensive maintenance, if they want to clean leaves or not to clean leaves, more sharps, a lot of things. And people don't know. They just don't know. But please look at the shadow. There is straight information. More than 70% of people want to have shadow. And we are not the country on the south of the Europe. We are just quite cold country. By the way, today I have 10 centimeters of snow outside, and we are surprised with that. So even in our country, people want to have shadow, because they feel that brings comfort to them. That was the scale of the country. We asked people in a little city, like 30,000 people, when we made projects of pocket parks, social pocket parks. So we ask people what they want. And again, you see that all of them, most of them, the most often chosen answer was just resting place in the shadow. So you see, needs changed. People don't know how to organize their space, but they feel that without shadow, their life in the cities is difficult. I started to check how it is outside of Poland. So if it's real problem. I'm sure that it is. But I was surprised that a lot of cities, not only Barcelona, I thought that it's only Barcelona, have even apps that you can ask how to go in the shadow from point A to point B. So not only Barcelona, a lot of cities now, they are trying to deal with that problem to improve the comfort of residents, even in that way. So green infrastructure started to be perceived in a different way like before. Before the ecosystem services like aesthetic was the most important. Now we need shadow. We need to improve thermal comfort. We need to manage water. So different needs are priorities. That's why that investment is the one of the main streets in Warsaw. That was the plan, how it will look like, quite nice, a lot of shadow. And after, on the end of the project, it looked like that. It was the project made 20 years ago. And even 20 years ago, it was absolutely not acceptable. People were protesting, and in the time of the guarantee, it's 5 times of guarantee when you will finish the project, everything was rebuilt, and big trees were planted, because that little trees, it's like a temporary plant for 1 year, for 2 years, for maybe for 3 years. It's not the plant that will bring us ecosystem services in hundreds of years. That's why people protested, and it was changed immediately. So now we are talking about functions of blue-green infrastructure. We are organizing sponge parks. So there is a park, of course, it's beautiful as well, but it has functions. It has that functions here. Function is main function is just retention. We are bringing nature into cities, even like a temporary, just to bring ecosystem services. You see here different layers of vegetation. Later we'll talk about that different layers are more effective in cooling, but in the rest of ecosystem services as well. We have trend to organize habitat gardens. So just we are going to that more natural direction. So natural sets of plants that usually they are growing together, and so we are adjusting plants into the site conditions. So of course they are beautiful because they should be beautiful. This is a very important function for people, but they are healthy, they are fast growing, they are long lasting, and they are bringing benefits, or flower meadows. So different kinds of vegetation, and we are talking about retention capacity of flower meadows and so on. There is a problem of leaves, and I don't know what is in different countries, but I see the wave of compulsive behaviors. People are trying to clean everything around, and they are fighting with leaves, and we need them. It's called organic matter. It's a food for biodiversity in the soil. Without biodiversity in the soil, we are not able to, for example, keep new planted trees, because that biodiversity is supporting new planted trees in the time of stress, in each time of stress. So when we have extreme weather conditions, more often still, biodiversity in the soil will support our green infrastructure. So we need education. We need to bring wild situations, let's say, normal situations like living leaves or keeping diverse patches of green infrastructure into the city. We are organizing low budget parks just to make the level of ecosystem services higher, or different activities that we combine, or functions, additional functions, that is social functions. So urban agriculture, people are learning how to plant plants that will bring them food, and by the way, in the meantime that greenery is bringing ecosystem services, it's biodiverse. Or new forms of green infrastructure like pocket forests. We had pocket parks, but now we are organizing pocket forests, like another form of green infrastructure. Even literally pocket forest will be important in the ecological system of the city. And the liters that I found is 3 meters by 3 meters, but the condition is we need to have just big trees because the size has a meaning. The size is the condition of efficiency. Even on our university, on SGGW, Warsaw University of Life Sciences, we have our pocket forest, and you see here a lot of people, and it was there were groups from the kindergarten till our rector that is just planting new trees, and that social event, so to organize, to plant, and later to maintain the pocket forest was highly important for our society. Even in the city, it was just positive social event. Here you have some information because the information is very important. We need to tell people that forest is important, leaves are important, soil is important. We can't damage the tree, we can't damage the soil because there are millions of organisms. So we are just bringing functions. Highline is a nice example how the functions, how to improvement of well-being was organized by that linear park and really biodiverse. Now that is an icon, that is a symbol of the New York, and people are coming from all around the world just to see that miracle in the place that was totally damaged, totally poor, without ecosystem services, so the temperatures were really high. Even pocket parks. On the left, there is a first one in the New York. It is an icon again, and it was just a form, beautiful form. It was the very important. It's very important. It was a very important place for city dwellers of New York, but the whole world knows that place. But nowadays, our pocket parks are just biodiverse because we need functions for well-being. So we are doing that to improve the living conditions of people and to deliver all that ecosystem services. One of them is just reducing the temperature and mitigating the heat island. Just to show that mitigation of heat island is not only trees and not only parks, and that we need different forms of green infrastructure. Each form of green infrastructure, each form is one little puzzle that is improving the situation on the city, and the diverse of the forms is important. I would want to demonstrate you some research about green facades. So when we don't have place for trees, we can just organize green facades, and they can just deliver the same level of ecosystem services like trees. They can add the work to the system. So that kind of wall could work like 7 linden with crowns diameter of 10 meters, or much more than 100 years old beech. And even here, I will deliver more information later. You have some information how it works. Yeah, so 500 square meters of green wall made of Partenocissus quinquifolia has water transpiration capacity, has transpiration cooling efficiency that we even demonstrate in numbers. So that is important, that we need to have numbers to put that work of green infrastructure into calculations, and that the same wall will improve the quality of the wall. The green facade construction lifetime will be extended by 15 years because it's just taking energy, and the extremes are flatter. So there is not so hot and there is not so warm. That's why the facade will live longer. But the same wall will absorb noise. And some research said that is something like 40% of sounds, and like reduction to 8 decibels, the same wall, yeah? And the same wall will have cooling, will bring cooling benefits, because 50% of the sunlight is absorbed, 30 is reflected, and that's why air conditioning runs 30% less intensively. So it means that we have energy savings, and the positive effect of reduction in the temperature is in average like 3 Celsius degree, and it's outside and inside, and it's the temperature in the winter outside is in the winter inside is higher, in the summer lower. So it just brings us a benefit and energy savings on cooling and warming the building. Again, I will show you some examples. United States calculates how the urban forest works for stormwater runoff. And the calculation is that it's reduction by 2 till 7%. And they calculated that investing in a green infrastructure is 3 till 6 times more effective in managing stormwater per $1,000 than different conventional methods. And still we don't have that kind of approach in our project. I hope you have, and I will love to listen that some cities manage to put that kind of calculation into their budgets or just investments. So I will show you how we calculate in the local scale, or we can just calculate, and a lot of cities doing that in the scale of the city, ecosystem services. That is part of the Warsaw. It's a Wola district. We just analyze, in that case, putting the air, so all that ecosystem services that are connected with air cleaning, and we calculated them. It's an example because, as I will tell you later, the benefits could be calculated from the point of cooling, but it appeared that 1,030 to 300 trees are working for the city, and the value of that work is almost 6,000 euro. And of course, we can demonstrate in the details, but even when we look to the PM 2.5, so it is work like almost 500 euro per year, but it is almost 10 kilos of PM 2.5. It's one of the pollutants that is really damaging for us, and everything is connected. So that trees not only clean the air, but as well they are cooling the district, that area. Of course, the highest the tree is, the biggest the tree is, the higher is the value of ecosystem services. And we made here some estimations, like in average, that is really useful later to make all another estimations or another analysis. It could be estimated for whole city. Just we need to have a data. So our the most efficient tree was a populus, and it was something like 30 euro per year, because usually it's just per year work. So each year. But we calculated as well replacement value. I just want to show you the tools that we are using for management, for urban forest management, urban greenery management. One is, as I told before, ecosystem services, so value of the work each year, which is, as you see, the highest for our tree. It was something 30 euro. But we also analyzed replacement value. And that 1,300 trees, it was something like more than 2 million euro value. And it's the value of the asset of the city, yeah? So it's a value of the, like buildings, like roads. Trees are a value, and we can calculate. Replacement value is perfect for that. And just to show some example, our populus, the most efficient tree. By the way, people don't respect populus genius. For them it's dangerous and doesn't have value, and that one was the most efficient. Even when we are demonstrating how much it works, how many kilograms of pollutants it's capturing, it's impressive, because what kind of method we will use to have that efficiency, yeah? And we can just calculate ecosystem services value, it's 16 euro in that case, or replacement value that is almost 1,000 euro. So different levels of monetary value, but both of them are important. So we know what is the value of our fabric, and we know what is the value of ecosystem services that it brings each year. So that is just pollutants, cleaning the pollutants. The whole value with energy savings and water management is like 3 times higher for the tree, more or less. So we can we are able in that way prepare some calculations and have just information for discussion. What is worth, what is not worth, how we can invest, because each tree is just investment. We are planting it at the value will be higher. That is opposite, like with gray infrastructure. When you will construct gray infrastructure, the value next year will be lower, and our tree value is higher. So we can calculate in ecosystem services value. It was like almost 6,000 euro in that case. We can calculate replacement value. In case of that trees, that 1,300 trees, it was more than 2 million euro. And we have just data to discussion. We can calculate another ecosystem services. It's mitigation of heat islands. And the calculation is based on cubic meters of evapotranspirated water, and surface land of limitation. Again, the same value we are analyzing, and energy consumption as well. IT Eco is because that software is working on another factors. So what we do to improve the quality of green infrastructure? City centers are really dense and covered with concrete, and that concrete must stay. Of course, some of them we can replace by green infrastructure, but some of them is not possible. And that's why we are trying to modify the subgrade of the pavements. So in that way, we can have all pavements, all roads, or parking lots that we need, and green infrastructure that we desperately need now, because if not, we will have problem. That's why to not disturb trees, not to damage, not to cut off trees, we are just putting basements on the roads, because that roots will work for us. We'll take water, will transpirate, and that transpiration will cool our cities. So we are combining gray infrastructure as a supporter of green infrastructure. That is something different, because usually gray infrastructure was damaging green infrastructure. That's why that is way how to improve site condition of tree, and to allow our investment to live, our investment like a tree, to live hundreds of years. That is a place where we have experimental plot, is just in front of my building on the university. We just are trying to We are just examining, collecting data to calculate the efficiency of trees. That is just preparation of our experimental plot. You have 3 pit here, and it's like 2 meters by 2 meters, and you have 2 parking lots with structural soil. And it's 5 by 5, so 25 square meters. So both of them, it's almost 13 meters space for roots. It's the space where we are capturing water, because in the subgrade could be even filled with water. We are delivering by that little orange device water from the rain and oxygen to the roots. And we have place where ecosystem services came back, and that is connected with concrete. Here we have porous concrete because we wanted to check how it works, and we are just looking for new possibilities. One function that is important for porous pavements, it's a function of cleaning. So PM 2.5 or 10 just going into, and they can be taken by the biodiversity that is just in the subgrade of the pavement. That is the new approach that we are trying to propose in the hardest sites, so the most concrete sites as our parking lots, as you see. And that is something that I want to show you, because we put 2 cubic meters into 2 parking lots, and we were able to manage that water. So it was infiltration process, it was evapotranspiration, it was transpiration by roots. It will be higher in the future. And now we are just measuring that. And of course, except of the capacity of the subgrade about water management and the potential of cooling, we have work of our trees. So we can add both things together. And here you have calculation, some model, kind of model for our small tree, like it is now, so just after planting. And it's a €9 value of ecosystem services. But when that tree will be large tree, normal tree, adult tree, it will be €120 value of ecosystem services. Of course, we can calculate, separate some of them and demonstrating separately, like here, so that our little small tree is something like 2 cubic meters per year to manage. Only 3, and additionally, we have the capacity of our grey infrastructure, and being large, because it has nice site conditions, it will be more than 30 cubic meters to capture, to manage. So that will be transpirated, evapotranspirated, that will infiltrate. It will make that place cooler. We suspect that it will be huge differences. That's why all that dots are sensors. We are just collecting data to know more about heat island mitigation potential, about the differences between our pavement and normal pavement, about the efficiency of trees, that will the transpiration of trees. We'll use porometers to tell the difference between trees that have access to water, because our trees have access to water, because the structural soil is just a source of water for them, and the trees in 3 pits, like 2 meters by 2 meters. So I hope next year I will demonstrate more interesting data about our research. And that is just temperature. So we can see differences in normal pavement, our pavement with structural soil, but just we need a little bit time to demonstrate them. Just need longer time to demonstrate the results of our study. So we can use not typical tools. to plant trees in the places where they normally, in a standard way, can survive. It's too hot for them, it's too dry for them, it's just extreme site condition. So that's why we are using gray infrastructure that could be just transportation, because it has enough parameters that are good for all kind of traffic, even heavy traffic. We have in that subgrade retention capacity till 0.31 cubic meter per square meter of that solution, and we just need to have that modification, because having that is delivering site condition, that is improving site condition for new planted trees. That's why they will grow to till being big tree, and big tree is efficient tree. We need at least medium-sized trees, because they are working visibly. It's just a level of ecosystem services that we need. Of course, the best level is the work of just big trees. So we can use that solutions for new planted trees, but we can use that solutions even for existing trees. So how to, coming back to the questions, how to manage urban forests, how to manage urban infrastructure. On our area, as you see, on streets, we had tree canopy cover 16%, in parks 85%, like in a real forest. In average, it was 30%. And the 30% is the level that it's enough to maintain thermal comfort, to maintain water management, to slow down runoff. So we need minimum 30%. But not only for that, there is thousands of studies, and that tree canopy cover like 30 or 33% is demonstrated like the canopy cover that significantly reduces stress, anxiety, and depression. So we are talking about Heat Island, but the rest, 19 ecosystem services, it could be delivered with tree canopy cover at least 30%. That's why that rule 300 appeared. That is discussion with a previous rule by Dr. Frank Santamor, that 10, 20, 30, that was the rule for biodiversity in the urban forest stand. And the researchers went further, and what it means, the functions on the city are the ecosystem services are on a satisfying level when we can see from the window free trees, that when we have at least 30% of tree canopy cover in the neighborhood and 300 meters to the nearest park or green space. And that is nice rule because it's really complex. Each number, it's a lot of studies that is confirming that that level of saturation with green infrastructure is that minimum that is working. I will demonstrate you later a lot of examples of that. So when we have that free trees is better when we have fewer large size trees than large number of smaller ones. That is, of course, it could be more, but just again, the size has a meaning. About 30%. It's that when there is that 30% or more, it's a condition to maintain well-being of city dwellers in a whole range of ecosystem services. It's a physical health, reduction of air pollution, cooling, microclimate, and that 30% is the minimum level. It's specific, like a minimum level. And 300 is distance to the nearest green area. And with a good quality. What does it mean, good quality? It could be a size like at least 1 hectare, because that area is efficient, but size of half a hectare should be set as a minimum. Of course, it's good when there is just a system of that kind of green areas to deliver to city dwellers. So whole cities are checking how it works on their area. Barcelona checked how it is, how many of people is living in that conditions, and only almost 5% of dwellers, city dwellers, fulfilled all 3 criteria of that rule. And they have the best mental health, they used less medication, they fewer visited doctors, so their health was better in comparison to the different groups. About Toronto. Toronto checked just prices of the buildings, of the flats, and checked if that flats, that place for living with fulfilled that our rule are the most expensive, and of course they confirmed that. In Toronto, 12% is living in the places where 3 criteria are fulfilled, but 26% did not meet any element of that rule. And that is a question of that social justice, yeah. So just to access to such kind of to the well-being, to the places where is the best way of life. If we can, of course, analyze which criteria was fulfilled, which not, in which situation, that is a nice tool for management. We know where is lack of good quality of green infrastructure, which districts, which streets, and we can improve, we can manage, we can deliver that good living conditions. So this can mitigate heat in urban ecosystem. It could be tree canopy cover can create 10-degree temperature differences. I will show you detailed analysis just to prove that, and how much greenery is enough. So even little improvement, like when we are improve 20% of tree canopy cover to 30%, it was the city that checked that avoided 3% of total mortality. But even 5% increase in tree canopy cover brings important result, like 300 fewer deaths. So we can even in that case analyze how it works, because when you have heat, especially heat waves, there are peaks of mortality in the city. It's a lot of studies that are showing that. So that is another very important issue. So residents with low socioeconomic status, they experience the highest improvement when we just improving the tree canopy cover in the area. So it's quite easy tool that is just a powerful tool for environmental justice. One nice slide, that is a study of Novak, as I remember, from 2007. And 2007 is like 20 years ago. And that is a way how in that time ecosystem services were perceived. So mostly, I remember that from the beginning of my own studies, that aesthetic was the main ecosystem services. There was, of course, runoff, air quality, CO2 reduction, sequestration, and energy savings. but aesthetics were perceived like a main ecosystem services. Now priorities change totally. We need to have energy savings, heat island mitigation, we need to reduce runoff, we need to improve quality, and so on. And aesthetics is one of the very important, but not the most important nowadays. So priorities change. That is what we need to face. So we have tools how to manage our urban forest. We have replacement value, we have ecosystem services that can help us in the management, in the decision making process. We can that could be basis for benefit cost analysis. What is important? We need to just manage the money of the city as well. Education is needed because that lack of knowledge about the natural processes, what is helping us, in fact, that you should leave the garden in your leaves, the easy things, but important things for the whole ecosystem of the city must be realized. So we need to educate people. If not, they will be not understanding what we are doing, why we are doing our efforts, and how that improves the life of the city dwellers. We can set standards. We are in Poland. We are on the phase of standards. How to deal with infrastructure, how to plant trees, but we can plant trees in a really high standard. Warsaw has standard how to plant trees, and they are not surviving because it's too hot in the city, because it's not enough water, because the site is so hard for new plants that they are not surviving. That's why that 30% of tree canopy cover and more, that are conditions that will help even new plantings to survive. So not only people, but as well even new plantings and new green infrastructure. Okay, we need some few minutes of break, or we should go further.
Maybe some questions, short break for questions. And if there's not, we can continue.
Maybe the questions could be on the end, because I can see the chat. So maybe on the end we will ask. So now
so I think we can continue.
Okay, so now will be the list. I just it was fascinating for me. By the way, I was going deep into. I started to analyze studies, because it's a massive amount of number of papers that is now published about how to make the efficiency of green infrastructure higher. I will demonstrate you that from the point of view of heat island mitigation. So what in fact have trees to the heat reduction in the city, species diversity has an impact. Yeah, that is the very important question. I will show you, even not species, but maybe forms. So structure of the green infrastructure, and what urban solutions will increase the effectiveness of trees in heat stress fighting. So just to remember, thermal comfort is one of the ecosystem services. We are experiencing a lot of more. We are saying that is 20 connected with trees and 100 just connected with nature. And how it works. So a lot of studies, I tried to choose some nice examples. From the easiest thing, large Acer saccharinum, we can evaporate more than 260 liters of water per hour on a hot summer afternoon, and that is equivalent of efficiency of 5 large-size air conditioners. So we are talking about one function, yeah, one ecosystem services of the tree could cool down the temperature. Cities are calculating that work, and very often they demonstrate it like energy savings. And in the London, we have Quercus and prunus like a most efficient tree for cooling, because efficiency of species is different, as I know now, and that is a reduction of 30% of energy in cities, savings a lot of millions of pounds each year. How it works, even in the scale of little house. So when we have 7 strategically planted trees, they can reduce cost of the energy by $400 a year. But when we will plant them in a in a different way, we can even make that cost higher. How it works? So when we have conifers, for example, on the north and northwest part of the building, they will block the speed of the wind, and where we'll plant trees with leaves on the both sides of the building, they will have leaves in the summer, so they will produce shadow. They will not have leaves in the winter, so the sun will enter into the building and warm it up. That is the approach that they propose. And it's really a significant difference when we properly arrange the greenery around the building, not only private building, each building, and the reduction of the heating bills, the energy bills could be even up to 30%. And later I will demonstrate that nowadays it's rather energy savings on the cooling than on the heating. Of course, a lot of studies about that. So that is a city in Nigeria. And you can see on the graph unshaded and shaded, tree-shaded building. And of course, they recorded changes in the temperature of the buildings in the whole year. And they calculate that is something like more than $200 per month on energy costs. In that case, mostly on cooling. There are some scenarios analyzed in that case. So there is a scenario with no trees, the scenario with current situation that they have, so trees but not very high trees. There is scenario with higher than building trees, and first scenario is trees that are different species than current situation. So they tried to assess if changing the species could improve the situation. So the simulation showed that the scenario 2 in comparison to 1, it was the 10% of savings. In scenario 3, where we have higher than building trees, it was 15%. And when we changed in the scenario 4 trees into the, as I remember, Tilia species, it was the 12% in comparison to 10% of scenario 2. So we just improved the situation a little bit. So we can improve the situation by size of the tree, but even by species of the tree. That is nice study about modern buildings with glass facades. We know perfectly that there is a lot of problem with the temperatures. We need a lot of cost of cooling costs in that case, and they just they organized shed belts, like trees in a shed belts, and they reduced significantly wind speed, and energy savings that they recorded was like 18% of the total heat energy cost by that shed belt trees around naturally ventilated office with glass facades. Another simulations, how to deal with heat. So that is simulations when we have rows of trees. There are little trees, they are big trees but close to each other, and big trees but with distance between them, street trees. So street trees decreased cooling energy demand for both the building that were checked by combination of shadow effect and lower convective heat transfer. That is important as well. The higher foliar density was important because it was more efficient in radiation blockage. And the higher energy savings, up to more than 50%, have been achieved when the trees form in a continuous shading canopy. So the continuous shading canopy works in the best way. What, of course, we could suspect, but now we have in numbers that is up to more than 50% energy savings. Another nice study. We have evidence that energy savings, especially in case of cooling, are significant. They are right from 2% till 90% cooling, and 1% till 20% of heating. Of course, they are very depending on the situation. So planting medium to large trees around 9 till 10 meters away from the west wall of the building shows the largest cooling energy savings, followed by the east. Planting too close to the building will not bring us that result, because in the winter they will shadow too much. They have been potential conflict with the building, so needs of cutting and so on. So that 9 to 10 meters away from the wall is recommended as the best distance for tree planting. And now a little bit about biodiversity. That is incredibly interesting topic that was started to be analyzed, studied last years very intensively. So some examples how it works. The studies showing that the same number of trees, the same size of trees, but more biodiverse, has higher effect on heat island mitigation. So the temperatures will be lower where we have the same structure of the urban forest or park, green infrastructure, but with more species. And some details about that. So here is the study in California, on California cities, and they analyzed Shannon Wiener index. It's an index that is telling us about biodiversity. It's possible to calculate it's on 3 species, and they checked how it works. So the correlation is really strong. So higher Shannon index, higher biodiversity, you see it here on the graph, is causing more cooling effect. So many species are correlated with more cooling efficiency of our urban forest. And here is that phenomena in numbers. So especially in hot days, like more than 32 Celsius degree, in areas with diverse tree cover, 1 unit in that Shannon Wiener index, so more biodiversity in the species, resulted 1 unit in 15% fewer of hot days. Influence of lower daily maximum temperature. 1 unit of the Shannon Wiener index in the tree diversity lead to up to almost 2 Celsius degree reduction in daily maximum temperatures. It's quite a lot. That effect is independent of total canopy cover, demonstrating that biodiversity itself plays a role in cooling. So even we don't need to extend so much, increase so much tree canopy cover, but just to change the set of species and we'll get the result. Warmer night temperatures. One unit in that index of biodiversity is correlated with till 0.6 degrees Celsius increase in minimum night temperature. Diversity grounds reduce temperature fluctuation. So again, the same like with green facades. We don't have extremes situations. And structural density, areas with greater variability of tree stem diameter and high of trees, greater diversity of high of trees showed more significant cooling effect. So not only species, but size of the trees and size so that the structure of the tree urban forest is important. So what is important? Especially in that higher temperatures, like more than 32 degrees Celsius, we will have maximum effect of green infrastructure by the biodiversity. Area with higher tree diversity had cooler days but warming nights, suggesting that isolating effect is like isolation. Species diversity may increase the ability of trees to cool cities, regardless of the amount of tree cover. So just the species diversity is important. Diverse tree stand can be a key tool in the city planning strategies to help adapt to climate change. So again, we have some tips, some informations, how to implicate that in urban planning to mitigate heat island result. That is again study how it works with high tree canopy cover. When we have high vegetation and like a situation like 90% of tree canopy cover, that conditions. So it appeared that when we have trees and shrubs, it's the effect is like decreasing the temperature like minus 0.9 Celsius degree. Trees in a production forest, so one layer is only 0.6, and rich forest, so regular forest, the efficiency is minus 1 and 1.7 Celsius degree. So again, biodiversity forms species is the most efficient. That works from different sides, that is resistant for different aspects. For example, storms have extreme weather conditions very often in the cities. So rich in a species forest is more resilient after storms. Functional diversity improved resistance and recovery, especially in extreme climates. Forest with native species were more resilient but slower to recover than fast-growing species. That is very important. That we get used to native species. Very often we are suggesting to plant in cities in Warsaw native species, but it seems that changing conditions suggesting us to make more species because we have changed conditions. So we have extremes in our cities. That is new aspect that started to be discussed in research. Climate and species composition interact to shape forest resilience to storms. So that is again nice study, and that is in that study the conclusion is that we have comparison of two stands. One have a richness like 2 species, another one has a richness of species like 6 species. And 2 species is quite diverse, the different forms, but only 2 species. In a situation when we have 6 species and different forms, that kind of stand will be more resilient than that previous one. So we need not only functional diversity, so different size of trees, but only two species, but we have as many diversity as possible. So different species, different forms. Why? Because if one of the here it was a situation. It was like 4 deciduous broadleaf species and 2 conifers. So if one that broadleaf broadleaf species will disappear, the rest will take his functions. So as much as diverse the forms and species are, as much the resilience of this urban forest is. So not only forms, but absolutely that richness of species is important and needed. That is another nice study and analyze how it works in urban neighborhood, local and individual scale. And what they checked? They checked that they found that investing tree cover from 20 till 50 degree reduces surface temperature in case of mixed forest patches till minus 3.4. When we have shrubs and grasslands, only -3. And when we have mixed forests and grasslands, till -347. So the most efficient is just mixed forms. Yeah. So not only mixed forest patches, but with grasslands will work them in the most way. Best cooling effect occurred when vegetation patches are larger and clustered, so close to each other, so that connectivity is important. Patch shapes, when the patch shapes are compact, like 1 hectare, or complex, more than 1 hectare, depending on size. So the complex of patches is important as well. So deep canyon and shallow canyons will demand different approach. Deep canyons, there is a situation when we have a narrow street and really high walls of buildings. Really high buildings are close to that shallow street. And shallow canyons, okay, we have bright street, very not so narrow street, and not so high buildings. So deep canyons requires trees with not dense canopies for airflow. That shallow canyons benefit from dense canopies. So you see that details are important. I always I'm telling to my students, and when I'm giving lectures, that in case of urban forest, it's not there is never situation like never and always. There are that little factors are making the difference. About layout of trees. Double linear plantings provides 1.7 times better cooling than single linear. So double lines are almost 2 times more efficient in cooling. Local conditions. Multi-layered vegetation, so trees, shrubs, herbs, lowers the temperature by in average 1 degree Celsius on sunny days, and 0.5 degrees Celsius of cloudy days. Double crown layers are more effective than single crown layers. Again, different forms are important. Individual tree. Species selection is important. Tilia cordata, for example, Tilia cordata is 4 times more efficient in transpiration than Robinia. Much more effective in cooling due to the higher leaves mass and thinner leaves. Crown structure is important. Trees with an umbrella-shaped crown provide the most shade and thermal comfort. This shape requires only 2.2 trees per 10,000 square meters to reduce temperature into the comfort. You can assess that comfort, so comfort of the users. Thin leaves have better transpiration and cooling capacity. Transpiration depends on the substrate, and that is one conclusion that I want to add something to that. So, of course, high albedo factor is beneficial because it will reflect the energy. So they conclude that combination with cool surfaces increases the cooling effect. On grass, the temperature is 10 times more than on the asphalt. So albedo. But when we have, that is to check, that is the study that we already do, that we have, when we have water in the pavement, that is to check if the efficiency of cooling will be high, how it is in comparison to a higher albedo factor. So a lot of things to put into that strategy, how to organize the city. So the effectiveness of cooling depends on the scale of the space being analyzed. The smaller the scale, the greater the importance of plant features. That is important. The smaller the scale, the greater is the importance of plant features. Trees can reduce air and surface temperatures up to 7 Celsius degree, depending on their type, distribution, and surrounding. Factors affecting cooling include crown cover, height and density, species diversity, climatic conditions, and substrate type. That is, that water in the substrate in the soil or in the, let's say, pavement, as I told before, could be crucial in that, and we can measure that. So we'll do that for sure. That's kind of study I couldn't find for now it on the databases. The best results come from diverse, multi-layered, and well-planned urban greenery. A little bit about, I have a few minutes more, canyons, because researchers checked urban canyon. So as I told before, very narrow streets and very high buildings. This definition of canyon. What they checked, what they found in canyons. So the situation with without trees and with trees, they just checked how it works in June, July, and August, and you see the difference in the situation with trees. So without trees is 11 Celsius degree. With trees in June, almost 5. In July, the effect is the highest, 13 degree. Without trees, and minus 2.25 Celsius degree. It means that temperature is lower than air temperature. And again, we have a result in August, 12 without trees and almost 6 with trees, canyon with trees. So maximum pavement temperatures without trees that they achieved was 53, 52 Celsius degree. It's a high temperature, and so it means that it's a quite difficult situation. And they found the temperature reduction potential like 10 till 15 Celsius degree, and best cooling effect was observed in the afternoon, like 15 till 17 p.m. Here, just you will get the presentation, so that is just the comparison, the situation, the canyon with trees and without trees, and even like we see now, that the differences are visible about street temperature, about roofs, about facades, and so on. So just to analyze. Convection topic is important. So they found the difference in situation with trees and without trees on roofs and on pavements. It's about radiation. That numbers demonstrate as radiation, but so there was a significant influence on cooling in that topic of convection, but in general, despite of that reduced convection, temperatures were generally lower in the presence of trees, so there was less need for convective cooling. So in general, it was just colder, not so hot situation. So trees can significantly reduce heat island, up to 70% in June and August, and even the most in July. We are talking about a situation in canyons. The effect of trees on cooling depends on wind condition. We can analyze that speed directions. The greatest temperature drop was so the greatest temperature lowering was recorded on pavements and buildings walls near to trees. Roofs and upper parts of building has less cooling effect. And you see, all that information that I'm talking today are now like a puzzles going into their place. We had that study about what will happen when trees are higher than building. Yeah, when we had the information what is about the world temperature in other studies. So that is just a picture of the whole situation, whole variants of situation. This can significantly protect against heat and reduce convection, which requires analyze and just to put them in the strategies of the cities. Maybe something like to another studies, just to finish. And Glasgow. Glasgow, what they checked impact of trees on reducing the heat island, and the situation seems to be really serious, as you see on the map, figure 9, and the summer average surface urban heat island intensity in the cities till 8 average. 8 Celsius degrees is a huge number of degrees. The main hot spots located in the city center and along the river of the city. We can see the situation. What they found? They checked different situation in the scale of the whole city, and they found that total green cover is correlated strongly, like minus 0.6, strong correlation. More greenery means lower surface temperature. Only trees a little bit lower, so moderate correlation. Trees are affected, but not so much like with total green cover. So the total green cover means trees, shrubs, everything is covered. Trees and plus grass, so two forms of cover is minus 0.49. Grass only is only minus 0.16, weak correlation, and shrubs minus 0.21. So as well, weak correlation. So the most efficient were or total green cover, very intensive greenery, or as you see, trees plus grass, following by trees only. So we have here what works in the best way. So experiencing such kind of huge heat island effect in the Glasgow, trees are the most effective element of green space in reducing surface and air temperature. Cooling effectiveness is greatest with canopy cover in the 50 till 100 meter range, small isolated patches. So little patches like 50 till 100 meters isolated, but when they are isolated, they are not ineffective. The Avenue program can significantly, because they have Avenue program, improve thermal comfort in the city center by reducing temperature extremes, and the selection of species. Again, they are proposing tilia. For example, tilia, because we need the biodiversity of species. So we need to know which trees are the most efficient in transpiration, and more or less we have some tips how to find them, what is the set of the species, and the replacement is very important. They can improve cooling efficiency by up to 40% more compared to other trees. So when we will change species, we can be even more effective. What is similar conclusion like in previous studies? And the last one study, but the most it's Chinese study, but really incredibly specific. So only tips how to deal with the heat island. We are just took the data from that paper and doing our own analysis. It was analysis on the campus. They checked the temperatures and average temperatures of buildings and roads. It was more than 40 degrees. Grass 32. The shaded area had 29 in comparison to 43 is a lot of a huge difference. The average of sharp, the cooling effect of shrubs and trees, they checked. They demonstrate that is from 10 till 11 Celsius degree. And the cooling effect of trees was 1.35 Celsius degree stronger than of shrubs. And now that is a list of factors that we can use in analysis. I really like that paper. So what about the morphology and cooling effect? What is important? Important is trunk diameter, tree height, tree crown thickness. And an increase in each of these parameters leads to the increase in cooling intensity by 0.5 Celsius degree. So when we have average trunk diameter higher than higher by plus 3.64 centimeters, it means that the cooling effect is higher by 0.5 Celsius degree. About tree height plus 1 meter and 82 0.5 Celsius degree. About crown diameter plus 0.85 is causing in the average 0.5 Celsius. About crown thickness plus 1.3 meters. And again, leaf characteristics and cooling effect, how it works. Cooling is increased by 0.5 Celsius degree with decrease in NDVI, vegetation index, by 0.02, decrease in leaf brightness by 10 units, reduction in leaf thickness by 0.03 millimeters. So you see, really nice parameters just to check in an analysis and to assess the cooling effect. And the relationship between species diversity and cooling effect follows the curve, as you see here. Cooling intensity is higher when diversity is either very low or very high. They found something like that. Of course, we need to check, go deeper how it works, why. And cooling efficiency starts to slow when canopy cover reaches 20%. At 40%, canopy cover cooling reaches its maximum efficiency, more or less. That is about significant difference. So it means that when we have from 20% tree canopy cover, between 20% and 40% of tree canopy cover, that is maximum efficiency. Of course, it could be higher, but that 40%, for example, Vancouver put that like a threshold. So they want to have 40% of tree canopy cover, and that is maximum. They decided to invest more. It's difficult, but doesn't bring significant effect. Yeah, and what is another factor is important. 80% of tree canopy cover is perceived in the city by city dwellers like a dangerous situation. In the forest, not, but urban forest, yes. So now we have just a tip what works the best and how to deal. And of course, the best cooling efficiency has Populus simoni. Here you have graph with sharps and trees about the species, which one was the most efficient, which one was the less efficient in transpiration. So even without deeper investigation and research, you have some information what is the most important. Amorpha fruticosa was the most efficient tree sharp in that set of that species that they found on the campus. Of course, different species exist. And just to finish, trees have a large higher cooling effect than sharps. We know how much. The tree species with larger crown diameter, thicker canopy, and the thinner and darker leaves would have higher cooling intensity effect. The spatial distribution of tree species at the cluster scale is important for increasing the cooling intensity. When the tree canopy coverage is larger than 40%, the cooling intensity had no more increase or is increasing in the not significant level, on a not significant level. Aggregation, connectivity, and diversity of tree species and a certain threshold should also be considered to produce a better cooling effect. The efficiency threshold and the proportion of different tree species need to be determined in advance to achieve better cooling effect in the cities. So we have a lot of information. That is something a little 2 or 3 more. And the last slide. So when the characteristic of green spaces, that is efficient in cooling. Forest and large green spaces have higher cooler effect than parks and small garden spaces, and irregular shape improves cooling for large but not for small green spaces. Again, nice information. How to make the biggest efficiency of cooling. About just characteristic of leaves. Specific characteristic of tree species can affect surrounding temperature and leaf type, leaf thickness is the example of the feature that we can analyze. And in the groups of trees can affect surrounding temperatures variation. An example of the variation is the height of trees with high variation of the cooling effect of parks. High of trees, but there is set of features that we analyzed before that can help us, not only high, but just a lot of information said before. So that is just the efficiency for climate heat island motivation. Each city is different, each situation is different, each district is different, even street. So I suppose that having that kind of set of information, we can prepare strategies for cooling the cities.